Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving container with most water. I will go over 2 ways to solve this problem, but I will only go over the coding for the optimal solution. If you're only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given an integer array height of length n. There are n vertical lines drawn such that the 2 endpoints of the ith line are I0 and I height of I as their x and y coordinates. And we want to find the 2 lines that together with the x-axis form a container, such that the container contains the most water. And finally, we return the maximum amount of water that a container can store. So if we look at this example, the maximum amount of water that it can store would be used with this line and this line because they are 7 blocks apart, and the minimum height between the 2 would be 7. So that's a length of 7 and a width of 7, and 7 times 7 would be 49. And that is the maximum of water that this problem can store. So how can we solve this problem? One way that we can solve this problem is that we can make a nested for loop, so it will look something like this, and that could set up our length. So I could be at one end of the length and j could be at the other end of the length, and the width would be the minimum of the height of these 2 indexes, and then we'll multiply that by index right minus index left, and then so for each I we will match it with each j, which would be every index to the right of I, and then we will do that for each I, and then in the end we will return the maximum area that we have calculated from each I and each j. And the time complexity of this method would be O of n squared because we have 2 for loops that are nested. However, there's actually a more efficient way to solve this problem, and I'll go over that one right now. A slightly more efficient way to solve this problem is that we can set up 2 pointers and we can calculate the area that we can form with these 2 pointers. And after calculating the area, then we can shift left or shift right depending on which index has a smaller height, because we want to keep the index with a longer height since it has a potential to have more length to calculate the area. And we want to continue that algorithm until these 2 pointers meet. So let's just go over this example. So from here, we have a width of 8 and a height of 1 because the left pointer can only has a length of 1, but the width could be 8, so the area is 8, and so far our max is 8. So we shift left. Now this could form area of 49 because the width is 49 because it's about 7 blocks apart, but the length is also 7 because 7 is the smaller height of the 2, so that's the most we can fill. So since 7 is smaller, we shift the right pointer. So we have a width of 6 and a height of 3, so that forms an area 18, but the max is still 49. So we shift the right pointer again. So we have a width of 50 and a height of 40, so 49 is still the max. So 8 times 5 equals 40. But since both sides have equal height, it doesn't matter if we shift left or right. But for this example, I'll just shift left. But if you shift the right pointer, it doesn't really matter. You will still get the result of the problem. So we have an area of 24 because the width is 4 and the length is 6. So 6 times 4 equals 24. Since 6 is smaller, we shift the left pointer. We have an area of 6 because the width is 3 and the length is 2. So 2 times 3 equals 6. Since 2 is smaller, we shift the left pointer again. Form an area of 10 because the width is 2 and the length is 5. So 5 times 2 is 10. So we shift the left pointer again since 5 is smaller than 8. This forms an area of 4 because the width is 1 and the length is 4. 4 times 1 equals 4. So we shift the left pointer again. Now that the 2 pointers have met, we can return whatever the max area is, which is 49 for this example. So the time complexity of this problem would be O of n, because in the 2 pointers algorithm, we will go through each element in the list once, and n stands for the length of the list or array. And the space complexity would be O of 1 because we are not using any extra space. So now let's get to the coding part. So first, we will set up the index of the left pointer. We'll call it left, set to 0. Then we set the right pointer, call it right, and it will be the length of height minus 1. And then we'll start the initial result at 0 since we have not had any calculated areas yet. And the algorithm will be while left is less than right. So while the 2 pointers haven't met, and we will calculate the area. So the area would be the minimum of the height of left and the height of right. The minimum between the 2 multiply by the right index minus the left index. So times right minus left. And the result will be the max of whatever the current result is or the area that we just calculated. And if the height of left is less than or equal to the height of right, then we will shift the left pointer by 1, so left plus 1. If that's not the case, then right minus 1, so we shift the right pointer. And when the algorithm finishes, we can just return the result. Alright, let's see if it works. Okay, perfect. Well, thank you all for watching. I hope this was helpful. If you guys have any other questions or comments about the video, feel free to leave it down in the comment section below. And I hope to see you all again soon.